In this video, we'll implement a backend feature which we'll later use in a canary release. We'll use popularity filters to filter song recommendation results. Checking the API documentation, we can see that they have a min, a max, and a target popularity parameter. We will implement the feature taking a top-bottom approach. Navigating the package structure, we can easily find our input adapter that we need to modify. This input adapter is the recommendations controller. We need to add the previously mentioned parameters to the recommendations controller. First, we'll write a test for the controller to check the controller's parameters are correctly passed to the input port. Here, we are not interested in the domain logic, so we return a dummy recommendation object. We use an argument capture to get the actual input object and assert its values. I had wrongly named the input port parameter with a command suffix. This is more a parameter object, and in any case, we are not modifying state but retrieving it. So it should have been a query. I will rename it with a query param suffix. The test has failed because we're not authenticated. We'll add this custom with log user test annotation to insert a fake authenticated user in the Spring security context. We try again, and it passes. We'll add the assertions to test for the newly added properties. From here, we're going to create everything needed to make our code compile. We'll add the min and max params to our input port parameter object. Now the test compiles, but our application code doesn't. We'll add the fields for the instantiation, and since we're here, we'll also add the parameters to the controller. Now if we execute the test, everything will pass. As we saw, one benefit of using one constructor with every existing property was that the compiler automatically complained about new arguments not being used when calling the constructor. But using a constructor with many params of the same type might cause hard to spot bugs when the constructor's argument order is messed. I know beforehand that Spotify's recommendations endpoint has many optional parameters, and that I'll want to add a few. So to make this instantiation more readable, I will take advantage of Lombok's implementation of the builder pattern. After this small refactor, I will run the test to check everything's okay. We have made our way through the input port into the getRecommendations use case in the application domain. This use case is very simple as it just queries the output port and uses the domain recommendation class only to sort its contents. In most cases for a reading use case, we would use simpler input parameters like identifiers. But our getRecommendations query param will have many optional properties. We might be tempted to take a shortcut and use the same class from our input port in the output port and consequently in the output adapter. But that would couple our input and our output. To keep our architecture decoupled and maintain the output intention in our output port, I'll duplicate the getRecommendations query param class in the output port and create a mapper within the use case package. Now we can make use of the output param in our port interface. Then we will have to adapt the use case to use this new interface definition and propagate the change to the adapter. Now we will create an empty output param that should make our future test fail, and fix our adapter with the new port definitions. We stepped out TDD to think about how we would map our input port to our output port and think about the architecture implications. The use case responsibilities are basically mapping between the ports to be able to make the call to the output port to obtain a recommendations domain object, and ask that domain object to sort its results. Going back to TDD, we see that although we tested the sorting behavior in the domain, we have no test that assures that the use case calls the domain sorting method. Since it's a similar test to the one we already did in the domain implementation, we'll fast forward to get to the testing of the mapping behavior. Now we could test the mapper mapping behavior, but we'll take a shortcut and at the same time make our test more robust. We could create a separate test class to test the actual mapping. Then we would mock the mapper in the use case test. But what we actually want to test is that the output port gets called with the right data. We don't care how the param for the output port gets built. We just want to make sure that the output port gets called with the correct parameters. So we won't test the mapper class itself and just assert our output port input. Let's start writing the test to make this more clear. We are going to create a captor to capture the output getRecommendations query param. And use it to check that it has the same values as the ones we're going to pass with the input params. Of course, I shouldn't forget to arrange the input params. Now, if we execute the test, it should fail because we hard-coded an empty output param in the use case implementation. There it is. It fails because the artist output param is null. We go back to the use case and create the mapper that will make the test pass. Mapstruct makes creating mappers a breeze, and we can always check the generated implementation. We get rid of the hard-coded param and use the mapper to do the conversion. Back to the test. And we see that our test didn't have a mapper to provide to the use case. Since we're using inject mocks annotation, we will just create a spike to take advantage of Mockito's injection mechanism. We execute the test again and it works. Having done the input and the use case, we'll go ahead and tackle the output adapter. The responsibilities of this adapter are just making use of the Spotify client to retrieve a recommendations object and map it to our domain recommendations entity. I'll skip testing the mapping since our domain entity and the adapter's entity are identical and I trust Mapstruct mappers. We'll replace the input list of artist IDs in our Spotify client with the output query param. We will jump to our Spotify client and test that we are correctly passing the parameters. To test we are correctly setting the input parameters, we will configure a Spring Web client with a fake exchange filter function. This will avoid calling an external service and just return an HTTP OK response. To test a real HTTP call and the mapping of the response, I have an integration test set up with WireMock. Since once the web client is created, we cannot modify its configuration, for each test we need to create a new web client with the assertion. Checking the exchange function definition, we can see we need to return a mono with a client response. I will pass a consumer function argument that will use the web client's client request to assert that it is well formed. The client request has a URL that we will have to parse to extract the actual parent. This is a little bit of code, but if we extract it to a method, the test will be quite readable. We are going to have to alter the arrange act assert a little and put the assertions before the acting. We execute the test and expect it to fail. It failed because we refactored Spotify client get recommendation signature, but we did not change its implementation, and is directly using the query param. Going back to Spotify client, we have to extract the query param's properties, the artist IDs in this case, to call the external service. We execute it again and it passes. These changes had to do more with the refactoring. We'll change the test to test for the popularity param. We execute it and fails because we are not using these params in the method implementation. We'll take care of this. We use the query param if present because we don't want to pass params with no values to the external API. Running the test, we check that we are green again. We'll start Docker, Keycloak, and Redis services and test the app with real traffic. We start the frontend locally to use the browser to get an example of a recommendations request. We'll leave the request with just the session cookie and use the GQ command line utility to format the output. We can map each track to a different JSON object to get a clearer view of the results. Now we are only going to print each track's popularity to play with our new filters. We see that there were 4 results that were below 60. If we apply a mean popularity of 60, we see that we no longer get results beneath this value. We do the same for the max value and works as expected. If you recall from the beginning of the video, Spotify's API had a target popularity param. If our backend is provided with a max popularity, I want to use it as a target popularity to return more results that are closer to that value to get more popular songs. So I'll use the mapper to do this. We could have placed the setting of the target popularity in the use case to make this business logic more explicit. Still, our mapper lies within the use case package, so our business logic still resides in the application layer. It would have been another thing if I had placed it in any of the adapter packages. This would have defeated one purpose of this architecture, which is to have the business logic centralized in one place. We'll go to the use case test and check that our property gets passed to the output port. It works, although we should have modified the test first to see it fail and then change the implementation to check that it actually fixes the test. Now, if we go to the output adapter, we will change the test to make it fail first. We add the missing param to the web client call and execute the test again. And it still fails. Of course, we're in the output port, and here our property should have already been mapped within the use case. We need to add it to the test input. We execute it again and it passes. We restart the backend with the new changes and we see that with the same query we get more results close to 70, which is the target popularity taken from the max value.